Hey everyone, Mr. Smith here. It's dark outside, but I'm on that grind, shooting video lessons for you guys. So let's get started. Today we're going to add and subtract rational expressions. Now I'll be upfront here. So today is kind of an algebraic skill. It's not required a ton in this course after today, maybe the tiniest bit. But it's required sometimes in grade 12 functions and sometimes in calculus. So it's not the be all and end all if you kind of struggle with it. The skill involves you need to be comfortable adding and subtracting regular fractions, and you need to be comfortable factoring, and also just like collecting like terms, distributive law. So there's a lot of things that, for those of you guys who struggled in grade 9 and maybe were in the 50s or 60s in the grade 10 course and still chose to take this course, if you haven't mastered those skills yet, you might find today challenging. But at some point, I just have to apologize or stop apologizing that you guys are expected to be able to add fractions and factor. We're in the 3U course. It's kind of expected you can do that. We've reviewed how to do that. And at some point, we just got to move forward without me just apologizing. Like, the course is what it is, right? But I'll still try to do my best to help you guys out. So in preparation for what we're doing today, we need to be able to add fractions. So let's just quickly review adding, subtracting fractions. Of course, if the denominators are the same, 2/7 and 3/7, they're like terms, right? It's like doing 2x minus 3x. It's -1. Instead of -x, it's -1 over 7. So when the denominators are the same, life is good. When the denominators are not the same, you need to make them the same. You need to look for a lowest common multiple of the denominators. And that requires, a little bit of numeracy. Looking at 2 and 6, what's the lowest common multiple? For these guys, it's 6. 2 goes into 6, 6 goes into 6. So we write each of these fractions as a fraction over 6. The second one was fine. But to do that, I have to multiply the first one by 3. 3 over 2 is equivalent to 9 over 6. I can now add those to get 14 over 6, or in lowest terms, 7 over 3. Now you can get away with that by just using a calculator, but you have to know the process in order to do what we're doing today. Your calculator won't help you today. In a case like C, the lowest common multiple, you just actually have to multiply 3 times 7. Here it's 21. And so we have to write each of these as an equivalent fraction over 21. 2/3, if you multiply top and bottom by 7, is 14 over 21. 4/7, if you multiply the top and bottom by 3, 12 over 21. And now you can subtract them. Why don't you try D? Looking for a lowest common multiple. Write each as a fraction over that lowest common multiple, and then proceed. So in this question, you don't have to use 60, although 60 is not wrong. The lowest number that both 6 and 10 go into is actually 30. And yeah, these are the kind of numeracy things that would probably be expected of a 3U student at this stage in their math careers. Shouldn't be too overwhelming. 5 over 6 is 25 over 30. 3 over 10 is equivalent to 9 over 30. And we get 16 over 30. Or in lowest terms, 8 over 15. But the big idea is to add fractions you need a common denominator. And so as we get to later on, adding rational expressions together, we're going to have to make a common denominator, but often from expressions that are algebraic, not just numbers. So let's dive right into that and see what I'm talking about. So here's two rational expressions, 1 over 5x and 1 over 2x. And for various reasons, other courses, applications, we may want to add these together. So how do we do that? Because right now, those two algebraic expressions do not have a common denominator. One is 1 over 5x and one is 1 over 2x. And they both have something in common. They both have an x, right? So that's good. But how can I make an LCM from the numbers? What's the lowest common multiple of the numbers 5 and 2? Well, it's 10. So in this question, the lowest common multiple would be 10x. So I need to make the first expression into something over 10x and the second expression into something over 10x. And what do I need to give the 5x in order to make it 10x? I need to give it a 2. So I'm going to multiply top and bottom by 2. And for the second guy, what do I need to multiply 2x by to make it 10x? I need to multiply it by 5. So I'm choosing to show my work this way. There are lots of other ways to illustrate this. These examples I'm doing now are, I believe for the most part, just lifted right out of your textbook. So, often, looking at these examples again after the lesson in the textbook can provide you just with different phrasing, maybe more detail, different colors, and you might find that useful. So 1 over 5x is equivalent to 2 over 10x. We've been talking a lot about equivalent expressions. Those expressions are equivalent. 1 over 2x is equivalent to 5 over 10x. And now that those denominators are the same, we can add these together, 7 over 10x. And the one restriction here is that x cannot be 0. So we've added our first rational expressions, and we've just used the skill of adding fractions together. We looked for a common denominator, a lowest common multiple. In this case, they each already had an x. So all I had to do was give the 5 a factor of 2 and the 2 to a factor of 5 to get 10. Then I could add those together. Let's try another one. So looking at these two rational expressions, we'd like to, in this case, subtract them, but those denominators are not like. So maybe here's another way to look at this one. 2ab squared. I'm just giving you another tool to use for looking for an LCM if you want. 2ab squared is 2 times a times b times b, right? And 2b is just 2 times b. So do I have to give anything to the 2ab squared, to make it look like the 2b? Like, no, it's already got the 2 and the b, right? So that's good. So all I need to do is I need to give the 2b, I need to give it an a and another b. So in order to have a lowest common multiple. So here my lowest common multiple would be 2 times a times b, or just the 2ab squared. So my first term is okay. ab squared plus 2 over 2ab squared. I don't have to give that one anything, but I have to give this guy, so b plus 1 over 2b. In order to get 2ab squared, it needs an a and it needs a b. The top needs an a and it needs a b. And at this point, it's just doing the algebra, distributive law, collecting like terms, all the skills that you learned in your grade 9 course and maybe thought, why am I doing this? I'm never going to use it. Well, we use it here. So ab times b is ab squared. ab times 1 is ab. And then the bottom is 2ab squared. Now that they are the same denominator, we can combine these. And if you have a look, we get ab squared, subtract ab squared. So those will add to 0, which is nice. And we get 2, and just be careful. We are subtracting ab, 2 minus ab, all over 2ab squared. We've simplified these guys. Our restrictions, not too bad here, so we'll state them. Looking at what makes the denominator 0, a can't be 0, or b. Those would make the denominator 0. So another example in the books, we had to find a lowest common multiple. In this case, what did we have to give the 2b to make it look like 2ab squared? And we didn't have to do anything with 2ab squared. So recognizing a lowest common multiple with algebraic terms, is going to be a new thing for you guys to get used to. Let's continue. So here's 2 examples that are kind of like the first 2 we did. Can you identify a lowest common multiple of 7a and 14? What do you need to give 7a? What do you need to give the 14? Can you do the same with 2a and 6b? So if you're watching this video at home, I would suggest pausing it. If you're watching this video in the classroom, I would encourage pausing the video and giving it the old college try. Just try. And then you can unpause the video when you've had a chance to try and then see how I did it and just get more examples in your notes. So I will assume that you have paused and tried and are ready to continue. And I have these done already. In C, the lowest common multiple is 14a. All you need to give the 7a is a factor of 2. And all you need to give the 14 is a factor of a. So you multiply the first expression by 2 over 2. The second one by a over a. Again, that doesn't change it gives you an equivalent expression, right? Because essentially that's like multiplying by 1. You get 10 over 14a minus 3a over 14a, and that's just 10 minus 3a over 14a. The restriction, a can't be 0. In D, the lowest common multiple is 6b. The lowest common multiple of the numbers 2 and 6 is just 6. And obviously the first term needs a b, the second term needs an a. So to make the first expression have 6ab on the bottom, you need to multiply it by 3, you need to multiply it by b. So 3b. For the second one just needs an a to get it to 6ab. I've distributed, so 3b times a and 3b times 2. I did a times b and a times 1, and then I collected all the like terms I could on top. Remember, when you add and subtract fractions, the denominator does not change. All right, so hopefully some more examples in the books. Again, this is one of the more challenging algebraic skills students encounter in their math careers. But I would argue it just involves our adding fraction skill, finding a common denominator, some expanding, some collecting like terms. Individually, each step can be manageable, but as you can see, there's just a lot of steps that build on each other. So it is okay to wrestle a little bit with it, but ideally, we all just are going to try our best. And if we're here at the start of the day, we're here at the end of the day. We just got a bit better, right? We won't be doing this all year long, but this is the part of the course where we introduce the skill. Let's move on, try a few more. Can't get worse, can it? Okay, so here's an example we'll do together. So in this case, we have some binomial factors in the denominator. In the previous ones, that was not true. We had like 7a, 14, those were all just single terms, right? So how do we deal with that? Well, it almost is a little bit easier. So if you recall, like for an example, looking back, say looking at C, 2/3 minus 4 over 7. 3 and 7 don't share, I should say it this way. The lowest common multiple of 3 and 7 is just 3 times 7. It's the product. You just do 3 times 7. It's a lot like this example here. The lowest common multiple of x minus 3 and x plus 2, there's no way to kind of mash those together to get a lowest common multiple. You just got to multiply them. So the LCM here is just x minus 3 times x plus 2. So that's it. You just multiply them. So they're not so bad. These ones aren't so bad. So what do we have to give the first term? We got to give it the x plus 2. Multiply top and bottom by x plus 2. What do we have to give the second expression? Well, we got to give that one the x minus 3 to have a common denominator. X plus 2 times x minus 3. And even though these, I've written them vertically so that you can see it's like 1 over, it's like those divide to 1 and they're equivalent. But of course, x minus 3x plus 2 is the same as x plus 2 times x minus 3. So now we can continue. So we can simplify the numerators. This just involves FOIL. So we have x squared, and you can do this in multiple steps. I can see that we're going to get 5x and 2x. That gives you 7x. At this part in your math careers, reasonable that you can do FOIL pretty efficiently, accurately. And on the bottom, usually we leave the bottom as factored. We don't need to expand the bottom. There are reasons for that. One is it's easier to spot restrictions, but there are other reasons you'll see in later courses. Let's simplify the numerator on the other guy. X squared, negative 7x and minus 3x, negative 10x, and then plus 21. Over x plus 2 times x minus 3. And then finally, we add the numerators together. And on the bottom, remember, those are like denominators. I'll just write x minus 3x plus 2. Those two things are equivalent. It's okay to, it means the same thing as x plus 2, x minus 3. What do we get? We get 2x squared. We're adding, so 7 plus negative 10 minus 3x. 10 plus 21 plus 31. Looks okay to me. Yeah, and then restrictions, we'll state restrictions because it's pretty easy for this one. X can't be 3, and x cannot be negative 2. So another example in the books, here the denominators were binomials, but finding the lowest common multiple isn't too bad in these cases. It's just the product. So multiply by that what it's missing, do a bit of FOIL, do a bit of adding like terms. Every step is manageable. We can do it, guys. Just going to take a bit of practice. I believe I have in this next one, yes, I believe I've said you try it. So this one in part B, literally the same question. The LCM will just be a product of x plus 4x minus 5. I would encourage you, if you're at home, pause right here and try it. In the classroom, maybe pause the video, give you guys a chance to try it. And again, just try. You can always erase it afterwards, right? And just copy down the right one, but just try. Maybe you find that you nailed everything except like a minor detail here or there, right? You want to start building up the confidence. So give it a try. So I will assume at this point that you have tried and you're ready to move forward. And so here we go. The LCM, maybe I'll write that in. The LCM, in this case, it's just x plus 4 times x minus 5. That's all you can do. First expression needs the x minus 5, multiply top and bottom. The second one needs the x plus 4, multiply top and bottom. That wasn't too bad, guys. Distributive law or FOIL. We get 2x. Oh, okay. That's glad I caught that. 2x minus 10. And the next guy is good. See, even math geniuses like me make mistakes. And I'm not embarrassed. I'm not upset about it. You just make mistakes in math, right? And it's all good. You just try to do better next time. And negative 10 plus 4 is negative 6. So that looks good. X squared. Yeah, x squared, 2x and 5x is 7x. Yeah. All right, and the two restrictions, again, they're pretty easy to spot here. X can't be negative 4, x can't be 5. So hopefully you're building up a bit of confidence. We have kind of one more level of problem to do. I think I have 3 more of these guys. So we'll do the this one together. And then maybe if you're at home, you can treat D and E like maybe one of those where you pause and try it yourself. Now, you may be wondering, okay, the bottoms here are trinomials. Am I going to have to multiply a trinomial by a trinomial to get a lowest common multiple? Well, you could to get a common multiple, but it might not be the lowest common multiple. What we want to do here is we want to factor the denominator in each case here, because maybe there's something in common, so I don't need to multiply by as much to get an LCM. So I'm going to do that factoring off to the right here as a little bit of an initial step. So with my first expression, the bottom is a simple trinomial, but adds to 2, multiplies to negative 48. That's negative 8 and positive 6, positive 8 and negative 6. Subtract. And the denominator, my second guy, what adds to negative 1 and multiplies to negative 30, that is negative 6 and positive 5. Now, the reason we do this is because if you have a look now at each denominator, they have a bit in common. I don't need to give too much else to the denominator on the left to make it similar to the one on the right. All this guy needs on the left is the x plus 5. And all this guy needs on the right is the x plus 8. So by factoring, we can save ourselves a bit of work. In this case, the lowest common multiple is x plus 8, x minus 6, x plus 5, all multiplied. And so now we can continue. What does this first guy need? That guy needed the x plus 5. All over x plus 8, x minus 6, x plus 5, minus. What did this guy need on the right? This guy needed the x plus 8. Multiply top and bottom by x plus 8. And I'm just going to make the numbers the same. I didn't last time, but I'm just going to put the x plus 8 there. Right? It doesn't matter where you put it. It's multiplication, right? And then the process is the same from here on out. You simplify the top. You see if you can collect any like terms. We generally don't expand the bottom, nor would I expect you to expand 3 binomials. That would kind of suck. So x squared, 9 and 5, plus 14x, plus 45. Now, I might, on the next one or two, maybe share some tips and strategies for possibly saving a bit of writing. In these guys, I've been showing every single step. Minus 9x plus 8x, minus 1x, and then minus 72. X plus 5, and then in this case, we're subtracting the numerators. So careful, we're subtracting, right? So x squared minus x squared, that's 0. 14x subtract negative x, that's 15x. And 45 subtract negative 72, that is 117. It's late though, so double, yeah, that's correct. If I make any mistakes I don't catch here, you guys can let me know in the comments. But yeah, and again, the restrictions here aren't too bad because we've factored right here. It's easy to see what makes the bottom 0. It was minus 8, positive 6, minus 5. And yeah, guys, that's like the highest level of problem in this case, where you need to factor a trinomial in the bottom to see if there's any kind of shared multiple that makes your finding the lowest common multiple a bit easier. But yeah, guys, look, I'm sure glad we did that because we only had to add the x plus 5 to the first one and the x plus 8 because they each had the x minus 6. So that was kind of helpful. All right, let's move on. So looking at, yeah, guys, looking at the final two, they are similar to part C. So if you're at home watching the video, you can pause and try these and just fast forward through me working on them to see what the answer is. Totally fine. If you're in the classroom, you can pause the video, give these a try, and come back, or you can just go through them with me if you just want a helping hand, a guiding hand for a few more examples. So whatever you choose, yeah, I'm just going to work through D and E. Again, feel free if you're bored of me talking and doing math to fast forward, just check your answers. But here we go. Let's factor. This guy multiplies to 32, adds to 12, 4 and 8. Expecting to see a factor, at least one of those in the next guy. X minus 2, x squared minus 16, difference of squares. X plus 4 times x minus 4. That's good. So you could write, if you want to keep writing out what the lowest common multiple is, if that helps you, you can do that. That is not a necessary thing to do, though, but it could be helpful. All right. We need to make the left-hand guy look like that. It needs x minus 4. And I think I'll show all my work for this one, and then maybe show you a way to save a bit of work on the next one. X plus 4, x plus 8, and this guy needed x minus 4. Adding x minus 2. And this guy had the x plus 4. It needs the x plus 8. Has the x minus 4. Of course, the top needs that x plus 8 too. Yeah, guys, a little bit of factoring. That's all we've done so far. Just a little bit of factoring. A little bit of expanding right now. So here's where some of you could just be like, okay, I know that everything is going to be over x plus 4, x plus 8, x minus 4 in the end. So why don't I just write it once and have everything on top? X squared, 1x minus 4x minus 3x, 1 times minus 4, plus x squared plus 6x, minus 2 times 8, minus 16. And then add the numerators. We get 2x squared. That's plus 3x. And then minus 4 minus 16 is minus 20. And restrictions. X can't be plus or negative 4 or negative 8. I won't always ask for restrictions. If I'm just concerned with you adding or subtracting these expressions, I won't always ask for restrictions, but they weren't too hard to do in these cases. So there's another one in the books, guys. We'll do one more. Yeah, I mean, just wanted to give you guys lots of examples. If it feels like overkill, it feels like you kind of get it, like that's totally fine. Just fast forward to the end. I will not be insulted. Now, for this one, and maybe it might be a good strategy for you, when a trinomial looks like it might take a bit of work to factor, maybe just do your work off to the side, right? I can common factor a 2 from here. Then I can see that that's a perfect square trinomial, x plus 3, or 2 times x plus 3 squared. So I've done that work to the side, and now I can just write the final form here. So x over 2 times x plus 3 squared minus 5. X squared minus 9 is the difference of squares. X plus 3, x minus 3. And now let's think of an LCM. What does the left hand need? What does it not have that the guy on the right does have? It has an x. It needs an x minus 3, right? The one on the right needs another x plus 3. It only has 1, but it also needs a 2. In this case, my LCM is going to be 2 times x plus 3 squared times x minus 3, just adding in what each side doesn't have. Let's continue. So this guy needed the x minus 3. And do I want to show, I think I was debating whether just to show a little bit of a step to save you a bit of work, but I think for the benefit of everybody, I'll just show this maximum amount of work for this step. So we have 2 x plus 3 squared, x minus 3. All this guy needed was the x minus 3, right? This guy over here, though, needs the 2 and another x plus 3. here's maybe where you can, you know what, I'm just going to show my work. Like, I'll leave it to those of you who can kind of see shortcuts, who kind of get it and can see how they can shave down some writing. More power to you. But I'm just going to show the maximum amount and then let you guys shave off steps where you're comfortable. And that's going to be 10. So 10 times x and 10 times 3, 30. 2x plus 3 squared, x minus 3. Subtract the numerators. So we have an x squared term. We have minus 3x, careful, subtract 10x minus 13x. And then we're subtracting positive 30, so minus 30. All over 2 times x plus 3 squared times x minus 3. And our restrictions, just x can't be plus or minus 3. So guys, those last three were very similar. So if you found them kind of repetitive, that's almost good. It means like, you're kind of maybe getting the idea. But I wanted to lean towards more examples than not enough examples. So that's my logic if you found this video too long and boring. But now we've got like hopefully a good broad array of types of problems in our notes laid out. I want to just remind you guys, most of these examples are laid out in your textbook too, with maybe showing the work a tiny bit different way, maybe a little bit different language. And maybe if you read through that, it kind of connects with you more so than how I word things. And that's okay. I also want to encourage you guys, as you are practicing from your text, remember that resource I've linked on Brightspace, video solutions of literally every single problem. So, and the site, I just checked it out, also has other examples of adding, subtracting rational expressions if you need more help. And the last thing I'll say too with this, guys, is that, this was probably the heaviest algebra day in the entire course. The rest of the unit is actually a lot of graphing. So it's a lot lighter on the algebra. What we're going to do is we're going to expand on the types of transformations you guys in the grade 10 course with parabolas. So remember in the grade 10 course, you shifted parabolas up and down and left and right. You stretch them to make them narrow or squash them to make them flatter. And you also reflected them so that they open down. We're going to do the same things: translations, stretches, compressions, and reflections, but with all the different new types of functions that I showed you guys earlier on. So it should be a lot of fun. So yeah, we are moving out of the algebra. We got that out of the way. Let's get some solid practice in, guys. Just stay positive. Just try to go from here to here in your practice. Just get a little bit better. Make use of all those resources that are posted to help you guys check answers. But until I see you guys next time, hope you're staying well. Have a great night, and we'll see you soon.